Hi and welcome to the video. In this video, I want to show you all the electronics that you need to build an RC airplane. The plane I am building today is called the Funcub NG from a German company called Multiplex. I have the body and I have got all these electronics to install in them. So this video is about giving you a rough idea on what you should be looking for and what are the parts that you will need from the electronic point of view to get started. So I'm going to use all of this today, but let's start one by one. So I'll just move all of this to the side. And we have a fresh canvas. So what do we start with first? And that would obviously be the motor. Why the motor? Because the motor decides a lot of things. How do you choose a motor? That is the first question. So the best way to do that is whatever model you're buying, or if you're building a scratch build kit, you need to go by what the manufacturer is saying in terms of their recommended motors. So motors are usually measured by their actual dimensions, that is the height and also the diameter of the motor, and more importantly there is a unit which is called the kilowatt rating of the motor. So if the manufacturer says that you need a 900 kV motor, what that means is you need a motor that turns 900 times for every volt that is supplied to it. So if you have a 5 volt battery connected to it, it would ideally do 5 into 9, which is 4,500 revolutions or rotations. So that is what the kV value does. But if the manufacturer says get a motor with 900 kV, it does not mean that you can get any motor with 900 kV. You can get a motor that is much smaller than this, which still does 900 kV. So what you need to look at is you need to look at both the kV rating that the manufacturer says, or if you're building a scratch build kit, then you can look up in the forums to see what kind of kV motors people are using. And second thing that you need to consider along with that is the size of the propeller. So this motor, for example, is a 985 kV motor, which is capable of spinning a 12 by 6 propeller, which is a 12-inch propeller. So if you get a much smaller motor, which is probably this this thick, when it comes to the motor, when it's this tall, it might still be able to do 900 kV, but with a propeller that is maybe 3 inches or 4 inches long. So that is what you need to look at. You need to look at the kV rating of the motor and the propeller size of the motor. That would give you a very good place to start with. So the motor I have here is from a company called Emax. It is the T2820 motor. This is a good fit for the Funcub NG that I'm building. What the manufacturer recommends is a 900 kV motor that spins a 13-inch prop. But what I've gone with is a slightly higher kV of 985 kV, but with a slightly 1 inch lower size of a propeller. So you will be able to do those mix and matches as you learn the hobby more and learn what thrust factor is, or how much thrust a motor can produce at a certain with a certain propeller and things like that. But that's advanced. So when you want to get started, look at the kV and also look at the size of the propeller that the manufacturer says, and try to get a motor which can do that. So this is the motor that I have right now. So when you get the motor, this obviously goes at the tip of the aeroplane, right? So let's put it here. So when you get the motor, there are a couple of things you need to think about, which is when you go to the spec sheet or the document that describes all the technical specifications of the motor, they will talk about the maximum current that this motor draws. So this motor here, 2820-06 motor with a 12 by 6 propeller pulls a maximum of 41 volts. So this is just 41 amperes. This is just something I got from the spec sheet of this motor. Why is that important? Because that is what decides decides the next component that you get, which is called the ESC, or the electronic speed control. So the electronic speed control connects to the motor, and this is what regulates the current that goes into the motor and controls the speed of the motor, right? So this motor does a maximum of 41 amperes, which means the ESC that you get needs to do at least 41 amperes if you're, if you want to risk it. But I would actually say always get something with a buffer of 5 amperes. So the motor does a maximum of 41. So plus 5, it's around 46 ampere. So you will not be able to find a ESC for 46 ampere. So I went with the next biggest, which is a 50 ampere motor. Oh, sorry, electronic speed controller. So that's the next thing that you need to choose. Now you understand why we started with the motor, because the motor dictates the ESC that you get. So we have the ESC. Obviously this ESC, we need to do some soldering and put some shrink wrap and things like that. But this is what it is. So this connects to the motor, and where does this connect to? So if you see the ESC, this is these 3 wires on one side, this goes to the motor, connects to the 3 wires of the motor. But on the other side, you can see he has 3 cables, 2 big red and black, as you guessed, positive and negative, and then a signal wire. So I'll tell you what that does. So the red and negative goes and connects directly to the battery. This is where the battery connects to the entire power system in the aeroplane, right? And then the ESC has a signal wire. This wire carries 5 volt positive and then ground, which is the red and black wires here. And then the white wire carries the signal, which is basically telling the ESC how much, what kind of a speed should the motor be turning at, which is what the ESC uses to kind of control the motor. So ignore this other lead, that is not required for now, but that's what the ESC does. So like I said, we get the battery connects to the ESC, and then we have the signal wire. So where does the signal wire connect to? So the signal wire connects to something called the receiver. So the receiver I have here is called the Radiomaster ER8G. So you can get any kind of receiver that you need, but one thing you need to think about is the number of channels that you need. So for a normal airplane with obviously the motor, the elevator, the rudder and the ailerons, you will need 4 channels. The plane I am building also has flaps, so it needs 5 channels. So you can get any receiver that has 5 channels or more. This receiver specifically has 8 channels, and this is a ELRS receiver. So if you're getting into the hobby, I would suggest one thing, which is when it comes to your control systems, always try, I think, without doubt, you should get ELRS systems. So ELRS is actually like a protocol for the control system to work on. It is open source, but there are various manufacturers like Radiomaster which build remote controls and receivers that work on ELRS. So if you're starting in the hobby, I would suggest to start, or not just start, just get ELRS, because it has all the features you can imagine and you will not grow out of it. So that's my suggestion. Obviously you can spend a lot more money and get things like Spectrum and Futaba, but this is what I would suggest. So coming back to the receiver. So the receiver is what receives the signals that you are giving to the remote control with your hand, and then transmits that signal to the plane. So the signal wire from the ESC that I spoke about earlier, that connects into the receiver, right? So how is the receiver going to get powered? As you know, the battery is connected to the speed controller. This battery does around 12 volts, right? Which is a lot more than what these can handle. They can handle only 5 volt. All the electronic systems other than the power of the motor, it runs on 5 volts. So what this ESC does is it takes the 12 volt from the battery and it will clean up and send 5 volt through this signal wire, through this cable, which has, like I said, a ground wire, a plus 5 volt positive wire, and then a white signal wire. So when you connect this to the receiver gets the power, and also the receiver can send the signal to the ESC, based on which the ESC will control the motor. So now let's spend a minute again with the battery. So if you see the battery, there are two important ratings that a battery will have, or that is how manufacturers describe our batteries, or actually 3 values. One is the number of cells. This is a 3-cell battery. How do you choose that? I would again suggest going with the manufacturer recommendation. And if you're getting a 4-cell battery or a 6-cell battery, you should also make sure that the ESC and the motor works with those number of cells of battery, number of cells, right? So this motor and ESC does work with 3-cell, and 3-cell is what the manufacturer recommends. So I have decided on 3-cell. What are the other 2 values? One is the capacity of the battery, which is the 2650 milliamp hours. And the next, also, how do you choose that? Again, go by what the manufacturer says. If it is a trainer plane and the manufacturer says go with 2500, that would be the right kind of capacity to give you the right balance between flying time and performance, right? If you're going with 3D and things like that, you can go lower or higher depending on what kind of acrobatic maneuvers you want to do, so that you can keep the weight of the plane lower, or maybe even increase the weight of the plane if you want to fly it in wind and things like that. So 2650 is the capacity, right? You should again go by what the manufacturer says, and once you are into the hobby for quite some time, you will be able to make your decisions on, can I go more, can I go less, seeing how the plane flies with what the manufacturer recommends. Now there is one more rating, which is called the C rating. I am not sure if it, it is here. So if you see the C rating here, it says 30 to 40 C discharge. So always take the lower number. This is basically a measure of how much current the battery can supply to the ESC. So when it says 30 to 40, 30 is what is the constant current it can supply. 40 is kind of the measure of current it can supply for brief moments, for a few seconds and things like that. But what does 30 and 40C mean? It does not mean 30 ampere and 40 amperes. That is the biggest mistake you can make. So how do you calculate this? So you first take the milliamp hour capacity, which is 2650, divided by 1000, which makes us 2.65, which is the 2.65 here, which is 2.65 ampere hours. 2650 milliamp hours divided by 1000 gives you 2.65 ampere hours. Now you multiply this 2.65 by 30. So 2.65 into 30 gives you somewhere around 70, if I am not wrong. 3 6 are 18, 6 7, 78 actually. So it gives you around 78 amperes, which is a lot of current. So what you need to take care of is, once you calculate the maximum current that the battery can supply, in this case it's 78, you need to make sure it is more than what the ESC requires. So this ESC that I have taken here is 50 amp hours, which means the battery I choose should be able to provide a minimum of 50 amp hours, should be able to provide 50 amperes whenever it's required. So if you look at it that way, I have a battery which has enough and more capacity or discharge rate to kind of support this ESC. Always again, don't try to meet it exactly. If it says 50 ampere on the ESC, try to have at least a discharge rate of 60 amperes. So again, 30 and 40C, you forget the higher number, go with 30, multiply 30 by 2.65 and you get 78. So 78 is a lot more than 50, so we are all good. So this actually is the power system of the airplane. So this is what provides the thrust or the these are basically the engines, right? Now the next big part of the electronic components that go into a plane are the control system. The control system's brain is obviously the receiver that I showed you here. The control system is what enables the plane to twist and turn and move in whatever direction we want. How do we do that? We do that by manipulating the control surfaces. If you are sitting on the window seat of a plane next to a wing, you would have seen some parts of the trailing edge of the wing moving up and down. If you're watching this video, I would assume you know what control surfaces are. If not, I think there are a lot of videos explaining this online. I hope you can check that out. So to move these control surfaces, we use something called servos. And the number of servos you need depends on the plane that you're trying to build. Generally, you will need one servo for the elevator. You will need one servo for the rudder. You will need two servos for the ailerons. This is what you will probably need for a typical plane. But in my case, I have a plane which also has flaps, which also needs two servos. So I'm going to just open this up. Meanwhile, I'll just talk about choosing your servos. So there are multiple kinds of servos. There are analog servos, there are digital servos, and there are plastic gear servos and metal gear servos. So let me first open up one of these servos. This is the servo I'm talking about. Yeah. So if you see inside this servo, there is actually a much smaller motor than this and a set of gears, right? These gears can be plastic or metal. That's what metal gear and plastic gear servos mean. Then analog and digital is basically how these servos are actually controlled. So here there is actually a potentiometer and it's an analog way of controlling the position of the servo. And in digital servos, you have a chip that kind of reads the signal and sets it using microprocessors. But honestly, you do not need to worry about that. I would say when you're starting out, get analog servos. But when it comes to plastic or metal gear servos, I would suggest to get metal gear servos. They are a bit more costly and weigh a little bit more. The same size servo, if it is plastic, would weigh around 9 milligrams, but this weighs around 13 milligrams because it has metal gear servos. Why metal gear servos? Plastic gear servos can strip very easily when you have mishaps on the field, but metal gear servos do not strip that easily and can last you a lot longer. And if you're really looking at a low budget build and you don't want to spend on digital gear servos, I would still say get the digital gear servos at least for the rudder maybe, because if it is a aeroplane which is a tail dragger, which means there is a wheel attached to the rudder on the tail, which is what controls the direction of the plane on the ground, right? You need to put a metal gear servo on that control surface. Or if you have a tricycle landing gear, which means there is a separate servo in the front controlling the nose wheel of the plane, and that is how it navigates on the ground. Then you need to put a metal gear servo on the nose wheel. Why do I say this? Because when you land and when you take off over rough surfaces, or if you have a rough landing, it is these landing gears which absorbs a lot of impact. And if it is a plastic gear servo, in a couple of landings you will end up stripping it. So if you are hard pressed on the budget, get metal gear at least for the surfaces that control the nose gear or the tail gear, depending on the kind of aircraft you have. So these are the servos. I'm going to just take all of them out. I've gotten all the servos out, so I'll show you where each and every servo goes. So you need one servo for your left aileron. It has to again connect into the receiver. Then you have one more servo for your left flap, which again connects to the receiver. Then you need one more servo for your right flap, which connects to the receiver. And then you need one more servo for your right aileron, that again connects to the receiver. And then from the back, you will need one servo that controls the elevator, which again connects to the receiver. And then you have one more servo that connects the rudder, and it also connects back to the receiver. So these are basically how the electronics roughly will be laid out in an aeroplane, in an RC airplane, right? I will try to put kind of a cutout of a plane distally so that you kind of can place where each of these things is, and it probably makes a much more sense with that. So these are all the electronics I've got, or these are all the basic electronics you will need if you are getting started with building an RC airplane. Now, there is one more optional thing that you can get, and especially good if you're starting out in the hobby and if you live somewhere where there is a lot of wind, and if it's too windy, it's very hard to fly. But if you have a gyro, which is what this is, it will be a little bit more easier to fly in when there are moderate winds. What does the gyro do? The gyro can do a lot of things. For a beginner, it can even auto level your plane so that when you let go of your sticks on the remote control, your plane is, it's not banked to any side or is not going up and down. It will just try to fly straight, right? But more than that, why we use gyros is basically to cancel out the movements that will be caused by gusts of wind. So if the wind is pushing the plane in a particular direction, the gyro will detect it with the accelerometers inside it, or the it will detect the movement that the wind is causing, and then it will send a signal to these servos to kind of cancel out the effect of the wind. So if it is going this way, it will send a proportional signal to turn the plane this way, so that it cancels out the wind's effect. That is what the gyro does. And how the gyro works or sits in this electronics pack is, the gyro basically will connect to the receiver, and all these servos will then connect to the gyro and not directly to the receiver. So the gyro will be like a middleman in the signals that go from the receiver to the servos, and then as and when it detects unwanted movements, it will send complementary signals to cancel out. Basically, this is kind of like active noise cancellation in headphones, where it sends an opposite wave to cancel out the sound. So this is basically what the electronics of a RC aeroplane looks like. I will also put the details of each and every component I have here in the description or on the screen, so that anyone who's building a Funcub Multiplex NG can try and replicate the same setup. So with that, I really thank you for spending the time and watching this video. I hope you found this helpful. If you have any questions, feel free to leave them in the comments. I don't get many comments, so I'm definitely going to read them and try to help you out if I can. With that, thank you for watching. See you on the next one.